Alright, many months ago, I shared a video
This keg almost killed me.
that showed me almost getting my head taken off by a projectile that flew off a keg. And in the video, we talked about how we had identified the problem and had come up with a solution for the problem, and we're well on our way to fixing the problem. But what nobody knows yet is that it actually got even worse from there. That's the story I'm going to tell you in this video, but there is a light at the end of the tunnel, so make sure to watch the entire video. Okay, so to recap, the keg I'm talking about happened to be a product that we were about to start shipping to our customers. At the 11th hour, we discovered the issue and paused the launch so we could come up with a fix. And that fix is a safety interlock system that we've actually been granted a provisional patent for. All right, so here is the actual finished keg, all of the metal parts. It's freaking awesome. We're super stoked about it, but getting here has been an absolute nightmare. So we thought we were done with prototyping easily a dozen times, but every single time we thought we were done, there was like one more problem. Here are just like a few of the prototype parts. There's actually a mountain of parts sitting here in front of me. So long story short, one of the things we did near the end of the project was send one of our tri-clamp designs to a safety engineer to make sure it was going to be strong enough to withstand the max pressure of the keg. Because there's actually a little notch that's cut out of this tri-clamp. Engineer gets back with us and says, good news, both of your tri-clamps are fine. They're plenty strong enough to withstand the pressure. But did you know that the keg body is not able to withstand the 60 psi rated pressure? To which we responded, this was confusing because the manufacturer of the keg body, which is an off-the-shelf part, has stated many times that the keg is rated to 60 psi, and once we pressed them on it, they said, well, I mean, you could actually push it to 120 psi. We take this back to the engineer. The engineer holds his ground. So we're thinking, all right, man, this engineer, I mean, maybe he just doesn't know what he's talking about. So we hire another engineer, and he comes back with the exact same information. We are concerned, to say the least. So at this point, I reach out to my friend Dan, who is an engineer. He actually does contract work for NASA. Fun fact, he's also a DJ. And I try not to run to him with every single problem I have, but this one I felt was worthy. So Dan pointed out that the model that the manufacturer gave to us was garbage. So we're thinking, okay, now we're screwed. But then Dan says the models that the other two engineers used are not very reliable either. So my friend Dan says, as he does almost every single time I call him with a question, that I need to do physical testing. The first thing we did was cut a keg in half so we could verify thickness of the metal at various locations. If you want to roast me in the comments for how I cut this or report me to OSHA, you know what? I understand. It actually gets worse from here because the engineers told us we literally need to try to blow one of these up. And I'm thinking, all right, so I need to blow up a keg. I thought this is what engineering school is for, so you could just make a spreadsheet of a problem that you're working through and solve it while you're drinking coffee at your desk. Blowing things up is dangerous, and that's literally what we're trying to avoid here. Anyway, long story short, Dan was right. We exhausted every avenue we could on the modeling side. It was clear that we were going to have to blow a keg up. The first way we thought we were going to potentially do this was with air pressure, though Dan cautioned against that because air is very compressible, and when you compress something, you are actually storing energy, and when that energy releases spontaneously and unexpectedly, well, that's what you call an explosion. Now you can see why we were so worried and why we didn't want to do the physical testing to begin with. So anyway, Dan strongly advised that we use water instead of air. Water is about 1,000 times more dense than air is and can't really be compressed like air. That's not to say that water at high pressure isn't dangerous, but for our purposes, water was going to be much more safe than air while doing the max pressure testing. So of all things, we went and bought a cheap pressure washer from Home Depot and managed to hook it up to several kegs. Both of the engineers that we talked to expected the kegs to fail at 100 psi or less. We got a number of kegs up above 500 psi, and we got one keg up to 700 PSI. Now remember that tire exploding at 150 PSI? Now you see why we were so worried about this and didn't really want to do the physical testing. No matter how hard we tried, we couldn't get a keg to explode so we could assess the failure mode, which actually would have been ideal, but the pressure got so high that the lids would warp and the gaskets would eventually blow out. So here's actually the aftermath of the testing we did. The keg on the left, this is our normal keg. That's what they normally look like. The ones that we subjected to pressure were literally blown up like balloons. This guy, I believe, is the one that we got up to 500 PSI, and then this one, 700 PSI. And to be clear, we subjected these kegs to numerous high pressure cycles. Speaking of life cycle testing, that's the other thing we needed to do to prove the integrity of the kegs. We pressurized numerous kegs from 0 to 60 PSI, back to 0 to 60, back to 0 for a number of life cycles, like 4 life cycles, I think maybe, or 5 was the max. Thousands of cycles for hours, a number of days in a row. 241. 242. It sucked. But what we determined was that after numerous lifetimes of pressure cycling, the kegs were fine. Nothing happened to them. They didn't fail, and we disproved the models. What we did then with the kegs that we had cycled was went and used them for the max pressure cycling that I had just spoke about. So the keg, for example, that we pressurized to 700 PSI, that keg had seen 1,000 pressure cycles before we pressurized it to 700 PSI. So with this information, we were confident that the models weren't accurate after all. The kegs were able to withstand the pressure that the manufacturer stated, and everything was good. Though this took a lot of time, energy, money. It probably caused a bit of brain damage for the amount of time that I sat and thought about this. Thankfully, we're all good. So at the end of the day, though, all of this was sort of for naught, because the longer we thought about this issue, the more we began to question why we had rated the kegs to 60 PSI to begin with. We've been using kegs for years to ferment and to serve beer and to quick carb, and never really pressurized the kegs to 60 PSI. In fact, most homebrew regulators have a safety release at 60 PSI, or sometimes even a little bit lower than that. We rarely ever go above 50 PSI, and oftentimes we just use 40 PSI. In fact, 40 PSI is the max serving pressure you would use for a beer. That's almost 4 times what you would put a CO2 beer at, and the max you would use for a nitro beer. So when we really thought about it, as the pressure increases, so does danger. And if we can reduce the pressure to a more appropriate, yet still a reasonable amount, that's not going to really take away any utility from the keg, why wouldn't we do that? So after all of that, we decided we're going to relabel the kegs for 40 PSI, and that is our official maximum pressure guideline for this piece of equipment. Do not pressurize more than 40 PSI. Why would you? There's no need for that. So that's how the kegs are going to be labeled. You'll still be able to quick carb a keg by setting it to 40 PSI and shaking it for a few minutes. And you'll also be able to carb overnight at 40 PSI from, 0 carbonation to, I'd say, a mid-level or mid to high-level carbonation at 40 PSI. And you shouldn't be serving anything higher than 40 PSI. Now, I need to address the inevitable trolls that are going to pop up in the comment section here. Since starting this project, we've received overwhelmingly positive feedback. Everyone is super stoked that we're making a cool new thing that's going to be safe and not hurt them, which, should be standard, but that's unfortunately not the case, everywhere with everything. Though no matter how often and how many times and how explicit we are about explaining the risks and the dangers of something like a pressure vessel, there are always folks who are just not going to get it. They're going to dig their heels in and push back and question the need for making a product that's not going to hurt somebody. And, you'll probably see some of that in the comment section. At the end of the day, your safety and our reputation is on the line, and as long as I'm in control of at least part of that, I'm going to do my best to make the safest and best products that I can. Speaking of, this product is available for pre-order on our site. We've started production of the final parts and they'll be ready soon, but there is a bit of a backup and we're fulfilling the oldest orders first. Definitely pre-order if you want one anytime soon. So anyway, hit that join or subscribe button and make sure and share this with your mom. If you liked it, thanks. See you on the next one.